All right, well, welcome back. Um, I'm going to go through a couple more examples of how to simplify, going through some different strategies on how to do this. So we have another example. So I'm going to call this example number 4, if you're following along at home. All right, example number 4. And what we have is we have this expression, and once again, we want to simplify it so it looks like cosine squared of y. Now, if you recall, our strategy is the first one, look for any identities. Look for identities. Okay, if possible. All right. And what do we have here? Well, identity, we don't have an identity here because it's just 1 plus cosine y. But we have one right here that looks a little weird. Sine negative y. If you recall, sine negative y does have an identity. Okay, because you have the y right here, it flips things around, and if you recall, that actually turns this into negative sine of y. So yes, that turns into negative sine of y. So instead of being positive, it's a negative. Okay, now after you look for identities and you plug them in, now you do some algebra. Okay, always simplify then. So now we're simplifying. And when we simplify, we're going to distribute this through. We have 1, and then we're going to have, since they're conjugates, we're just going to have minus sine squared of y. Ah, 1 minus sine, well, that looks pretty familiar because 1 minus sine squared of y is actually equal to cosine squared of y. And guess what? Cosine squared of y is exactly what we were trying to get to, right? Awesome. So let's try this one. If you want to pause it and try yourself before I go through the answers, that would be swell. Okay. All right, well, let's once again go through the strategy. We have cosine squared of beta plus cosine squared of pi over 2 minus beta. So another question is, how do we get to 1? Well, right here, cosine squared of pi over minus 2. Well, don't worry about the square, but look for the cosine pi. Look at identities. Well, that actually, cosine pi over 2 minus beta, that's the same thing, if we recall, as sine squared. So right here, this right here, we know is turned to sine. And so we actually have sine squared of beta. All right. And cosine squared plus sine squared, another identity, equals 1. My goodness gracious, great multiplier, and just what we're trying to do. You might think, wow, this is really easy. Okay, you gotta find identities, you gotta see them. Don't remember the square, just so everybody knows this. I'm just gonna write this over here, all right, because we can rewrite that just if you didn't know that. This is the same thing as cosine of pi over 2 minus beta, all right, and that quantity is being squared. And so when we got that right there, that sine, I changed this right here into sine of beta first, okay? And then that would be squared, and then we can rewrite it like that, okay? Just so you're aware of how we got there. Okay, final one, at least for today, is we have this one right here. And what are we gonna do with this? Well, we'll call this example number 6. You wanna try it at home, and go and try this, okay, and see how you do. Our goal is to get it equal to 0. We'll see. All right, we got 2 fractions, looking for some identities here. All right, and right there, I don't really see any identities. So the second thing is change it into sine and cosine, change into sine of x, cosine of x. Well, in this case, it's not sine and cosine of x. We have some y's too, but it's already in sine and cosine. So now, after we have that, do algebra. Okay, do some algebra. Do some algebra. Simplify. Sometimes we'll say simplify. All right, simplify. So now this is where we use our algebra tools that pay the bills. All right. So in order to add these together, what we're going to do is we're going to actually take and use the, all right, find a common denominator for each. So because we have 2 fractions mean find a common denominator. So find common denominator. All right. And so we have right here is going to be cosine of x minus cosine of y over sine of x plus sine of y. And I'm just going to multiply these by, the old trick is that we're going to take this one, and I'm going to multiply by this denominator. So we're going to go, this is going to be cosine, let's see if this works, cosine of x plus cosine of y. Let's see that right there. And if I do that, we're going to have cosine of x, all right, plus sine of y, right? Oh, sorry, it'd be the same. Oopsies. See, even math teachers make mistakes. All right, be cosine of y. All right, then we have to go plus. Well, now we're going to have sine of x minus sine of y over cosine of x plus cosine of y. But now we're going to multiply by this denominator right here because we have to get it common. So this one's going to be, but we can't just multiply that. And we're going to do top and bottom. Sine of x plus sine of y. And so when we have those, we're going to multiply them through and see what that will do for us. So the bottom, I'll just tell you, we're looking for 0. And when you have a fraction, when is this going to equal 0? It's when the numerator equals 0. So usually when you have a fraction, so essentially we're going to see if this numerator will equal 0. So I'm going to just write this right here. I'm not going to distribute this through. I'm just going to write this as sine of x plus sine of y times cosine of x plus cosine of y. I'm not going to distribute that through just yet because I'm going to save some time. But right here, I am going to distribute through. If you notice right here, these are conjugates. And so what happens is that we'll have this times this will be cosine of x, that quantity squared, right? The conjugate in the middle part will cancel out, but now we'll have minus, all right, cosine of y, that quantity squared. We'll add that to over here. Once again, we're going to have sine, right? Sine of x, that quantity squared. And then right here we'll have conjugates cancel out. We'll have minus sine of y, that quantity squared. Okay, so now from here, this is where it gets a little tricky, but we're going to put all the x's and all the y's together. So what we're going to do right here is this denominator is going to stay the same, but we're going to have sine squared of x. I guess I can put cosine squared of x right there. I'll group those together. Hopefully you're going to say, hey, I see something, Mr. Gutjock. All right, then we're going to go cosine squared of y minus sine squared of y. All right, we're going to group those together. And that's all over this right here. All right, I'm just going to say like that right there. Okay, I don't feel like writing it, but we're just going to simplify this numerator now. This right here, if you know cosine squared plus sine squared equals 1. Well, this is almost like that, but we're going to factor out a negative. So now I have cosine squared of y plus sine squared of y. And guess what that equals? That equals 1. 1 minus 1, well, guess what? That equals 0. So we have 0 over, now I'm going to just actually write it out. What I didn't want to write out all the time is we have sine x plus sine y times cosine x plus cosine y. And guess what? 0 over that is going to equal 0. Who knew? And if you notice, that's exactly what we wanted. And that's exactly what we got. Put some sprinkles in there for a little donut for us. All right, so some other problems, once again, going through the strategies, look for identities. Plug in the identity. Simplify by using other identities. Make it look like the left side. Very similar strategy when you did it in 10.1. Look for identities. Plug in the identity. Simplify, make it look like the left side, right side. When you're not given any identities, use algebra. When you have fractions, common denominator. Multiply them through, good things are going to happen. All right, you will have to use identities, some basic trig identities to help you solve it. All right, well, hopefully that helps you. Do some homework and some review. And remember, hopefully this will help you with some tests and quizzes in the future. All right, good luck and God bless.